For businesses like local contractors, medical clinics, and legal practices, inbound phone traffic dictates revenue. When the phone rings, there is money on the line. Marketing teams often assume their job is finished the moment an ad campaign gets a prospect to dial the number. The dashboard registers a conversion, and the lead generation phase is considered complete. This diagram shows what actually happens. The call bypasses the intended receiver and falls out of the funnel into an unmonitored void. The prospect hits voicemail, reaches a busy signal, or speaks to a representative who fails to log the details. The initial ad worked exactly as intended. The operational break occurred within the company's internal call handling and follow-up systems. An expensive lead is functionally useless if the caller's information dies immediately in an isolated call log without triggering a follow-up workflow. The standard industry attempt to plug this leak relies on deploying generic conversational AI bots to act as a digital answering service. These tools can speak to the caller and transcribe the audio, but they operate entirely outside the business's core infrastructure. Because the bot exists as a separate layer, the data it captures is stranded. The text transcript sits in an isolated dashboard, completely disconnected from the sales team's customer relationship management system. This diagram shows the architectural shift required to solve the routing problem. The base PBX routing layer locks directly into a language model, which is then capped by a layer of credential tools. True telecom automation requires embedding the AI directly into the phone system and CRM stack, granting the agent the authority to execute software commands alongside verbal interaction. To see how this tool execution layer functions in practice, we can trace a single inbound call as it triggers the LeanPBX system architecture. Look at the top node of this flowchart. A live call enters, and the AI receptionist immediately intercepts it. Before parsing spoken intent, the system runs a data line down into a database query block, using the caller's number to check existing records. Based on the results of that query, the AI activates its internal memory management protocols. If a match is found, the system retrieves the caller's identity and previous interactions instantly, before the caller has spoken a single word. A basic bot resets to 0 on every call, offering the exact same robotic greeting. A tool-using agent preserves the ongoing project context and resumes the interaction logically. Pre-human context retrieval elevates the interaction from a static data entry form to a continuous business relationship. If the database query returns no match, the system handles the interaction as an entirely new intake process. The agent shifts to its defined role instructions, asking specific qualification questions to determine the scope of the prospect's needs. But this introduces a severe operational risk. If a caller asks about business hours or specific services, an unconstrained language model will often guess and supply incorrect information. To block this behavior, the architecture queries a specific search knowledge block containing the company's verified documents and URLs. The system restricts the agent's vocabulary and factual boundaries to this uploaded dataset, actively preventing it from pulling assumptions from the broader internet. As the caller responds, the agent simultaneously parses the incoming conversational audio, extracting structured variables like the caller's name, email address, and specific project requirements. Synthesizing a human voice has no operational utility if the system cannot be strictly bound by verifiable knowledge guardrails to protect the company's liability and brand. This exact moment of data extraction is where the system pivots from voice synthesis to automated software execution. As you can see in the flowchart, the AI node fires a create contact or update contact command directly into the CRM database, while the caller is still actively speaking on the line. The system executes these commands with credentialed access to the business environment. Next, the agent executes a create note command, transforming the raw conversational waveform into a formatted text block attached to the CRM record. A human representative will routinely handle a fast-paced intake call, hang up the phone, and forget to log the exact project specifications. The software executes the entry flawlessly every single time. With the data secured, the system triggers an SMTP API call, branching an alert line directly out to the revenue operations team. The staff receives a perfectly structured, pre-qualified alert regarding the new prospect in real time. Returning to baseline pace. The commercial utility of this architecture lies in the marriage of instantaneous data entry and automated internal routing. While the back-end data operations finish executing, the live caller is still waiting on the line. The system evaluates the urgency, monetary value, and specific context of the data just collected. Based on those parameters, the flowchart completes as the AI routes the path down into a human extension or IVR node, feeding the caller directly back into the core PBX infrastructure. The caller seamlessly connects with a specific department, queue, or live representative without having to dial a separate number. This routing establishes a strict architectural boundary. The system is deliberately not designed to replace staff for complex contract negotiations or closing high-ticket deals. In a functional operational model, human staff handle the nuanced work of escalation and sales, while the software executes the initial intake and triage. A successful deployment ensures that human agents allocate their time exclusively to fully qualified, thoroughly documented opportunities. Understanding the technical mechanics of the flowchart is necessary, but we also have to look at the commercial reality of how this software is successfully deployed to businesses. In telecom sales, businesses are highly resistant to ripping out and migrating their entire existing phone system. It is viewed as a massive operational risk. Attempting to sell this architecture as a comprehensive, all-in-one PBX replacement immediately triggers that deeply entrenched fear of downtime and disruption. This diagram compares the deployment models. On the left, a full PBX migration fails to connect. On the right, LeanPBX solves this friction by packaging the intake agent as a standalone AI microservice that plugs directly into the side of the existing infrastructure. By isolating the complex routing backend into a targeted pilot program, the software solves a single problem without requiring the business to alter its primary communication stack. The most effective way to deploy deeply integrated infrastructure is to sell a focused, low-risk service that immediately stops revenue leakage. The immediate targets for this microservice wedge are lead generation agencies and call-driven local service operators, who incur financial losses from missed calls on a daily basis. Proving a measurable return on investment through a single, tightly constrained workflow, like handling after-hours intake, establishes commercial trust. Once that baseline trust is verified, it creates a logical pathway for the business to execute a full migration onto the broader PBX platform down the line. A basic chatbot simply reads text aloud. A tool-using agent actively investigates the caller, retrieves context, grounds its answers in verified documents, and documents the entire interaction. Telecom AI creates value by executing precise read and write commands within the CRM while the customer is still on the line.